Hey guys, just back again here. I thought I'd just do a quick video, just giving a general overview of my CNC mill. In the previous videos, I had some comments just asking a few particulars about it. So look, I just thought I'd do a quick video, just giving a general overview of just some of the components that I used. Basically at the front here, you've got a CNC controller. It's called a 9810. It's made by Adtech. Actually, it was made by Adtech. I'm not actually sure if they still make it. It's probably about 5 years old now. If they don't make it, they would definitely make something similar. They've got a whole range of different controllers. Inside here, we've got our brake resistor there for our spindle motor. And then following that, you've got a 40 amp, I think it's 40 amp RCD just for my input power. Next to that, you've got two 3-phase circuit breakers, one for a spindle motor and then the other for the Z-axis. And then continuing that, you've got your X, Y-axis, X-axis, Y-axis controller drawbar and Z-axis 240 volt circuit breakers. Now the Z-axis actually needs, so the Z-axis uses 3-phase 220 volt and it uses 240 volt AC just for the front of the controller there. I didn't actually plan on using this, so this is the drive here. I didn't plan on using that. If you look at a previous video, I planned on using a pneumatic balancing system and a much smaller motor. However, I decided to use this and I'm glad I did it. It's much better, much easier. It's got a lot more power and yeah, obviously don't have to use pneumatics now. So yeah, much happier I did that. The only downfall to doing this, obviously it's more expensive, but I also had to run a step down transformer from 415 AC down to 220 volt AC 3-phase. So just incorporated another voltage, which I didn't really want to do. You know, I've got, say now, 450 volt AC, 220 volt AC 3-phase, 240 volt AC and 24 volt DC. So look, I didn't really want to, but look, it's a much better option. If you could get away going with a maybe like a 3 kilowatt or you know, something like that for your Z-axis and not use pneumatics, I would, yeah, I'd probably give that a thumbs up if I was you. Next to that, you've got my motor overload and contactor for my coolant pump, which I haven't installed yet. I've purchased it, but yeah, haven't installed anything yet. I've still got a lot to do on this system, but yeah, just haven't really had the time. And then following that, just some 24 volt DC power and some relays. Next to that, just a 24 volt DC transformer, and then you've got your big spindle motor drive. I think I've mentioned on a few of the comments, it's made by CTB. They were really helpful. They were really good. So yeah, I definitely recommend them. And then down here, you've just got your X-axis and Y-axis servo drives. And then yeah, up here, you've just got just some I/O. So basically controller I/O there. I think it's input, top, output, and then just following that, just some spindle motor I/O just down there. Got the pendant there just for the, yeah, it's pretty easy. I think it's a 3-axis pendant, that one, it's pretty good. And then just up here, my power drawbar, probably here. Yeah, so that's basically the electrical side of things. It's a 5.5 kilowatt CTB motor and a BT40 spindle. I think the spindle came from AliExpress. Again, I probably purchased that ages ago. Just, you know, they're all pretty much the same, Chinese, you know, it's not too bad, really. So, and then going from that, you've got your 3.7 kilowatt Z-axis motor. Now this Z-axis column, I've got to do a video of this where I'm showing the difference in spindle deflection going from not braced to braced and then filled with epoxy. So that whole Z-axis column is filled with epoxy granite and the base is also filled with epoxy granite. So I noticed I just had a tiny little bit of deflection. I think about 2 mil of deflection on the spindle head, which is quite a fair bit with about probably 100 kilos of force. And I've dropped that to almost nothing now. So I'm just going from braced, you know, obviously check the deflection and then just filled with epoxy. So yeah, much better. And yeah, it seems to run perfect. Although I didn't really notice any difference without it. I just was sort of worried about it, obviously. You know, just pushing on it with that much force, I just noticed that deflection. So that sort of warranted me to going with epoxy granite, even though I thought it had a really rigid system. Like this is all 250 UB beams welded together. I think they're about 20 mil flanges. So like, you know, the system's really heavy. And yeah, look, I definitely thought I had a rigid enough system, but you know, we're always trying to make it as rigid as possible anyhow. It probably didn't help having the spindle motor in front of the spindle. I should have obviously put it at the back, but yeah, that's hindsight, I suppose. I can't do anything. Well, I don't really want to do anything about it now. But that's that. Yeah, so that's probably one thing I would definitely change. I would have dropped the spindle motor back there. I probably would have also changed my X and Y axis motors, probably a little bit bigger. They're 1.2 kilowatt. I probably would have gone slightly bigger on that side, but I'll run the system anyhow. That's just running the program there. Right about 5,000 RPM. And yeah, so that's that. I'll just send it home. That's going home now. But yeah, look, it doesn't get too much use. It's definitely handy, and I've got a lot of things to do to it. So obviously it's got to have its own enclosure, coolant pump. I've still got a lot to do to it, but yeah, anyway, I'll keep you updated, and there's a few more videos on it coming up. So yeah, cheers. Thanks for watching. Ta.